Hello everyone, so in this video we're going to talk about another interesting topic, which is photo-cycloaddition of alkene. Now up to this point we have talked a lot about the photochemistry, so I guess if you have followed this video series, you will gain much basic knowledge about the photochemistry up to now. So this is gonna be a quick video. It's gonna be short because we are going to introduce this cycloaddition reactions and how these cycloaddition reactions are affected by the photochemistry. Now if I take a quick example, like let's for now forget about this photo part, just consider the cycloaddition of alkenes, right? So most common example is like this. We have diene. I'm hoping you have familiar with this kind of reactions, right? These are in the organic chemistry. Now this is a diene, right? This is a diene and this is an alkene. I hope the symbolization is okay for you. I mean, this is CH2 and CH2 over here, and this is CH2 over here, and CH2. So I will stick to the line representation just like this. Now when you talk about normal cycloaddition reactions, what happen is this mechanism we call it as concerted mechanism. Right? We call this mechanism as concerted. Now what happens is, here we have an alkene. So this pi bond comes over here to form a bond with this particular carbon, and this pi bond shifts here. This pi bond is going to come and form a bond between this carbon. So the result will be like this. We have complete cyclomolecule like this. This is our result, right? Now there's a specific way to denote this, right? We call this 4+2 cycloaddition. Most of us they confuse this nomination, right? This means, this 4 means the number of pi electrons, right? The number of pi electrons involving in the particular mechanism, otherwise the reaction. So this 4 represents the one part and the 2 represents the other part. Okay, now in this case you can see this part over here, it has 2 pi bonds, which means 4 pi electrons. Now in this case, this has only 1 pi bond, which means there is only 2 pi electrons. Now if I go into a little bit a complex molecule like this, this is a hypothetical, right? Okay, here we have another molecule. Now in this case we have a molecule like this. Okay, now we have a alkene right here. So the reaction would be just like here. This shifts here, this shifts here. So we have a cyclo molecule. Only difference is there's another part, right? This. There's another part. Now if I ask you what's the symbol, right? I mean, what's the name like this? Like here, what's the value for this particular reaction, right? So this is not 6+2, right? So if you consider this segment, right, one of the compounds which involves in our reaction, so this segment has, you can see there are 3 pi bonds, 1, 2 and 3 pi bonds, which means there are 6 pi electrons. But the important thing, right, all these 3 pi bonds, otherwise all these 6 pi electrons are not involving in the reactions. As you can see, only 2 pi bonds are involving. This pi bond over here, it's not involving in the reaction. So for this nomination, right, for this nomenclature, we don't consider this pi bond. So this actually 4+2. There are 4 pi electrons which are involving from this side, and there are 2 pi electrons which are involving from this side. So this is 4+2 cycloaddition. This is one of the most important points in the cycloaddition reactions, right? So now let's move on to the point which is the photo-cycloaddition reactions. Now when photochemistry is involved, if you remember, we have talked about this, the effect of photochemistry to our particular reactions, you will know that when photochemistry is involved, now when our molecules are get excited, this pi bond is getting weak, right? So what happens due to that? Let's take an example like this. So here we have two dienes. Now we have two dienes. Okay. Now the reaction mechanism would much more tend to go towards radical mechanism, right? Because the weak pi bonds, these are tend to break. So what happens here? Now this one form bonds right here, and this one forms bond right here, and this one forms bond right here, this one. So we have the particular structure like this. So this one, right? As you can see, there are two new bonds are forming, right? From this carbon to this carbon, a new bond is forming. This carbon to this carbon, new bond is forming. So here we have a structure like this. Okay, this is the structure we have. This is the structure we have. This is go through the radical mechanism. Radical mechanism. Okay, what about another example? Let's take another example, shall we? So here we have another example. Now we have this one. Okay, which is going to form a structure like this. How can you arrive at this particular answer? Like, this is the product you have, right? Sorry. There's a small mistake. There must be two bonds. This is the product. Now I'm asking you, like, you have to try a particular radical mechanism to achieve this particular product, right? So we can go it like this. So as you can see, there are two carbons is separated from the ring here. This is our whole structure. So there are a separate part here which contains two carbons. So I will break these two carbons, right? I will break these two carbons, not carbons, I mean bonds here. I will break these two carbons to here. Now rest one. So I have the structure. So let me erase this one. Sorry, I can't erase it. Yeah, I will draw it in here. Now we have the structure. It just like this. We have formed a bond between these two guys. We have two radicals here, and we have the bond here, and there's a pi bond over here. Now we are closer, right? As you can see, we are closer to our original product. Now the next step would be what happens. There are two radicals here, so I'm going to push these radicals to form a new bond here along this unbroken pi bond. Now we have this particular structure, right? So this is the mechanism. Now as a final example, let's take another one. So the same reactant, the same molecule. Okay, we have the same molecule. I want you to try the mechanism, the radical mechanism to obtain this guy. What about this? Now I hope if you can see it clearly, I mean, like, if you have the experience from here, you will clearly see how to do it, right? I mean, you can see these two bonds here, this one and this one, which are same, right? Here you can see these are same, so there are no reactions, or otherwise no difference would happen at these places. Only the bonds which are changed are these two. So you can see these bonds have become like a cross, right? I mean, they have bonded with each opposite carbon. So what I'm going to do is a thing like this. I'm going to break each of these bonds. So here I'm going to this bond, I'm going to break this bond and bind it together. So I'm going to put this one here and put this one here. We have the product right now as like this. So we have the two bonds unbroken. This electron and this electron has formed a new bond between this carbon and carbon here. Now there are two electrons which are in the radical form has been left. So now the next step, I hope it's obvious, right? So we can combine these two guys, so we can obtain our final product. Okay, so these are radical mechanisms, so we are going to look more into these type of reactions. For now, let's take this introduction for our next few videos. I hope you understand about this photo-cycloaddition reactions, right? So main thing is mostly in photochemistry, right? The reaction would go through a radical mechanism, right? It's go through a radical. Why? It's because when your product, or otherwise when your molecule is excited, your pi bonds are getting weaker, right? We have talked this in many times in our previous videos. I hope you remember that when the excitation happens, the antibonding orbital of the pi orbital is getting occupied, so bond load is getting decreased, our pi bond is getting weaker. This weakened pi bond resulting in much more feasible breakage. So radical mechanism is possible. That's why we are introducing radical mechanism for the photochemistry. Now in next videos we are going to talk about individual chromophores like carbonyl groups and phenols likewise. For now, I hope you get the idea. If you have any problem, please feel free to comment below. I will try my best to answer your questions.